Welcome to this Blazor DataGrid tutorial. In this video, I will show you how to connect Microsoft SQL Server data to the Syncfusion Blazor DataGrid component using a web API adapter, an entity framework. I will also show you how to implement CRUD operations in the DataGrid. Let's start by creating the SQL data. I've already launched Visual Studio with a Blazor web app. I open the View tab, then navigate to SQL Server Object Explorer. Next, I expand the SQL Server, followed by the local database instance. After that, I create a new database named Orders Details. Next, I will create a table named Orders for the data source using a SQL query. I will start by choosing the New Query option. Then, I write the SQL query to create the table named Orders. This table includes fields such as Order ID, Customer ID, Order Date, and Freight. I also set Order ID as the primary key, which is essential for enabling CRUD operations. When I run the query, the Orders table will be created. To locate the Orders table, I expand the database and then open the Tables folder. Next, I right-click on Orders and select View Data from the context menu. A new tab opens where you can see the table in a grid format. Finally, I insert some sample order data into this Orders table. Next, I will create the DB context and model classes from the newly created Orders Details database. Before proceeding, it's necessary to install two essential NuGet packages. This package is used to generate the database context and model classes directly from the database schema, making it easier to work with Entity Framework Core. This package serves as the database provider that enables Entity Framework Core to interact with SQL Server. So, I open the NuGet Package Manager and search for Microsoft Entity Framework Core tools and select it. Then, I install the required version. Next, I search for Microsoft Entity Framework Core SQL Server and select it. Then, I install the required version. Once both packages are installed, the application is ready to scaffold the necessary classes and begin building the web API. So, I open the Package Manager console and run the scaffold command. Scaffolding saves time by generating the model and context directly from the database. This command includes the connection string, data provider, and output directory. The connection string contains the server name and database name. After running the command, I navigate to the Data folder in Solution Explorer, where I can see the order model and the Orders Details context class files. In the Order class file, you will find the order model with fields that match the SQL data. Next, I navigate to the Orders Details context CS file. This class is a partial class named Orders Details context that inherits from DB context. It has two constructors, one default and one that accepts options. The DB set for orders allows us to query the orders table easily. In the onConfiguring method, the connection string is defined directly in the code. In onModelCreating method, Entity Framework configures the order entity. Order ID is set as the primary key with a specific name. Customer ID has a maximum length of 100 and maps to the corresponding column. Order date is defined as a datetime type. The onModelCreating partial method allows manual additions if I expand the model later. Next, I open the app settings JSON file located at the root of the Blazor project. Inside this file, I create the section named Connection Strings. This section is specifically designed to store database connection strings in a structured and centralized way. Next, I will add a new key value pair under the connection string section. First, I define the key as Orders Details Database, and the value is the full connection string that points to my database. I ensure that this connection string is the same as the value in the onConfiguring method of the Orders Details context class. To register the database context, I navigate to the program CS file. Then I register the Orders Details context by calling the addDBContext method. Also, I link it to the connection string using the key. Now, the context is secure and ready. To add an API controller, I will create the controllers folder in the application. Then, I will add an API controller by selecting New Item from the menu. From the list of templates, I choose API Controller Empty Template and name it Orders Controller. When I click the Add button, the controller is created. Inside the newly generated controller class, I declare a private field to hold the database context. This allows the controller to interact with the database for operations like retrieving, adding, updating, or deleting order records. Next, I define the constructor, which receives orders details context through dependency injection and assigns it to the private field. To get order data from the database, I first add the HTTP GET attribute to identify an action that supports the HTTP GET method. Next, I define a GET method that returns all records from the orders table along with the total count. This helps populate the data grid with initial data. After that, I add the HTTP POST attribute to identify an action that supports the HTTP POST method. Next, I define a POST method with the newly added order details parameter. Inside this, I implement logic to add the new order details to the existing orders and save the changes, which is used to submit new data to the server. Then, I add the HTTP PUT attribute to identify an action that supports the HTTP PUT method. Then, I define a PUT method with an updated order details parameter. Inside this, I add logic to update an existing order based on the received details. It updates the fields and saves the changes to the database. Then, I add the HTTP delete attribute with the root parameter ID. This identifies an action that supports the HTTP delete method. Finally, I define a delete method that accepts the deleted order ID. Inside this, I add logic to remove the order from the database based on the received order ID. Also, I save this changes to the database, which is used to remove data from the server. Next, I return to the program CS file. Then, I register the controller service by calling the addControllers method. This method is used to register the controller services with the dependency injection container. Next, I will add the mapControllers method. This maps the controller routes to the HTTP request pipeline, allowing the application to handle incoming HTTP requests. Now, the API service is fully configured. I will show you how to connect the Blazor DataGrid to an API service. To do this, I will navigate to the HomeRaiser component, where I have already added the Syncfusion Blazor DataGrid with grid columns for displaying order details. If you want to see how to add the Syncfusion Blazor DataGrid component to a Blazor web app, check out the video linked in the YouTube card above and in the description below. To connect SQL data to the DataGrid using a web API adapter, I will use the Syncfusion Data Manager component. I have already installed the required NuGet packages in the application. Next, I navigate to the Imports Razor file and import the Syncfusion Blazor Data namespace. This allows me to use the Data Manager component in the app. In the HomeRaiser file, I add the Data Manager component. Next, to link the controller URL and Data Manager component, I define the URL property and set it to the controller URL. Then, I set the adapter property to Web API Adapter. Everything is now configured. I run this application. In the output, you can see the Blazor DataGrid displaying with SQL data. To enable CRUD operations, I add the Grid Edit Settings component. This component is used to configure and control the editing behavior of a data grid. Next, I set the Allow Adding property to True. This enables adding new records to the grid. Then, I set the Allow Deleting property to True. This allows deleting records directly from the data grid. To enable editing, I set the Allow Editing property to True. I set the isIdentity property to True to make the order ID column read-only in the add and edit forms. I also ensure the isPrimary key property is set to True for CRUD operation. Next, I define the toolbar property in the DataGrid component and set it to include buttons labeled Add, Edit, Delete, Cancel, and Update. In the output, you can see the toolbar with provided buttons. I can also add a new item with the required details, and click Update. Now, you can see the newly added record in the orders list. These changes are also reflected in the SQL database. Next, you can edit an existing order and update the changes. The edited record is updated successfully. Finally, you can remove any order item, and the record is deleted successfully. Now let me summarize. In this video, I showed you how to connect SQL Server data to the Syncfusion Blazor DataGrid component using a web API adapter and entity framework. I also showed you how to implement CRUD operations in the DataGrid. If you'd like to see the working code for this example, you can download it from the GitHub link in the description below. Additionally, I provided a link where you can check if you qualify for a free community license to use all our Blazor components. If you found this video helpful, don't forget to click the like button and subscribe to our channel for more videos like this. Thanks for watching.